Have you ever wondered how TypeScript actually knows the types of variables when you don't explicitly type those definitions? So like here, TypeScript figures out that greeting is a string without us actually explicitly stating it. Well, in this video, we're looking at what's called type inference or type inference. I'll be honest, I don't actually know how that word's spoken out, so I'm just going to go with inference. But anyway, it's a simple feature that exists in a lot of strongly typed languages, including TypeScript. And it's really powerful for helping you write more readable and clear code. In TypeScript, type inference is the ability of the language to automatically determine the type of a variable or an expression based on its value. So that allows you to write less code while maintaining type safety, and that helps prevent errors without being overly verbose. Type inference makes TypeScript not only robust, but it also keeps it user-friendly as well. It strikes that balance where you don't have to specify the type of everything manually, but you do still get the benefits of a typed language. So consider a situation where we declare a variable is finished and we give it the value false when we declare it. So TypeScript doesn't actually require us to specifically say that is finished is a Boolean, but it is a Boolean. TypeScript has inferred the type based on that assigned value. So that really simplifies the code, and it also reduces the likelihood of introducing errors just because we've been too much effort into types. So another example might be with a function. So we start by defining a function called add, and that's going to take two parameters, a and b, both of which to be declared to be a number, and we're just going to return a and b. So inside that add function, we're returning the result of adding those two things. And since both of these are numbers, TypeScript's going to automatically infer that the expression a or b will also be a number. And that provides type safety when this function is used. So I can call add here. So if I do result is add 5 and 3, you can see that result will be a number. If I hover over it, it's got number there. And we didn't actually explicitly put :number at the end of this function, but it's done the type inference from the function. So just like you can do type inference on variables, you can do type inference on function types as well. A great aspect of TypeScript's type inference is its support for more complex types, such as arrays and objects, right? So when we assign an array or an object to a variable, TypeScript infers the specific structure or the type of its elements or properties. So if you're actually trying to declare arrays and variable types when you declare a variable, it gets super complicated. So it's really handy to be able to rely on types inference in TypeScript to be able to do that for us. So thanks to TypeScript's type inference, if I go down a bit here, if I hover over this, you can see that it's actually picked up that number is an array. Now this is fairly simple for if it's just numbers, but if you've got really complicated arrays of objects of arrays, having type inference is really useful because you don't want to be putting loads and loads of declarations over here on the left-hand side. We can also look at another example. So when initializing an object, TypeScript determines the structure and the types of its properties. So here it infers person as an object with a string name and a number age. So that inference provides clarity of what the object is supposed to contain, and it prevents you from accidentally assigning or accessing properties that aren't intended. So if I hover over this person class, you can see the IntelliSense has picked up that it's got a name property and an age property. The automatic determination isn't just limited to variables. TypeScript also infers types with more complex constructs, like return types in functions. So first we'll define a type called person, which is going to represent the structure of an object. Now our person object is going to have a name, which is going to be of type string, and it's going to have an age of type number. Now I'm going to declare a function called print details, and that's going to take in person as its object. So it's constraining the object to be one of these objects with name and age. Inside the function, we'll just do console log, and we'll create a template string here to say person age and person name is person aged years old. After that, let's create a constant Bob, which is an object with properties name and age. So in here, we'll say that he's Bob and he's 25 years old, and he's also going to have an extra property of occupation. If I call print details on Bob, TypeScript allows that because Bob does at least fulfill the type of person. So it shows that you can add extra properties in here, like occupation, but you can still pass it in as a person. So in that print details function, although Bob has an extra property of occupation, TypeScript happily allows Bob to be passed in since all the properties of the type that are expected by the function are present. So TypeScript accurately picks out the right types in the fields, and that helps maintain flexibility without any explicit operations. So that's several examples of type inference in TypeScript. It's important to understand that where explicitness is still necessary though. So while type inference is really good and it's really powerful, it doesn't cover every scenario. Sometimes providing that explicit type annotation can really help convey the intended use of a variable or function. And a lot of people that don't like relying on inference, this is the big thing that holds them back, is they like to be able to know what type it is by reading the code. So you need to balance between doing inference everywhere and explicit type definitions, just so that when you're writing your code, it can be safe, but it can also be readable by most people here and there. So don't go overboard, but don't use it absolutely all the time. I think a balance is key. So I'll give you an example, right? In a more complex scenario, such as a mixed type array, the first element is going to just be a 1, the second element is going to be a string, and the third element is going to be an object with count 3, so an object with a property inside it, basically. So TypeScript's inference is going to let us look at this mixed array type and say, look, this is a mixed array that can be either a string, sorry, let me hover over that, either a string or a number or an object with count inside it. And this is where type inference is really useful, because you could declare this manually. You could say, let mixed array is of that type. But how horrible is this to read, especially if it got really, really like verbose and long. So it's actually really useful to be able to just take that off, hover over it. If anybody's coming into reading in the code, they're likely going to be using an IDE that supports IntelliSense like this. So inference is super, super useful when you have lots of really complicated arrays like this. You know, we could put a date in here as well, and it would just add that to the inferred array here. So you can see we've also got date. Type inference is a fundamental aspect of TypeScript, and it drastically enhances developer experience by reducing boilerplate while still keeping the benefits of static typing. Understanding when and how TypeScript is going to infer types will help you write cleaner and more efficient code. Remember, the more familiar you are with these principles, the more intuitive your TypeScript will end up in the end. So make sure to be familiar with this feature of the language, and if you want more TypeScript related videos, I have a whole playlist on the channel that I'm putting together right here on YouTube. So have a look in the video description right now, or check out this video on your screen here. My name's James, and this is the Trends Code YouTube channel.